Normandy, June 1944. The hedgerow country, a maze of death. Allied forces found their advance a bloody, grinding crawl. Amidst this brutal landscape, a singular German weapon cast a long, terrifying shadow. The Panzerkampfwagen VI Tiger I. This 56-ton Leviathan was a symbol of engineering might. Its 88mm KK-36 L56 main gun effortlessly pierced 100mm of frontal armor on any Allied tank from over 1,500 meters. For Allied tankers, facing a Tiger meant almost certain destruction. Its formidable presence fostered a myth of invincibility. This perception, however, obscured a fundamental paradox. The very complexity of its overlapping road wheel system, designed for unparalleled off-road agility and comfort, concealed a critical, unforeseen Achilles heel. A seemingly insignificant technical vulnerability lurked within its otherwise imposing design, ready to be exploited. Weighing 56 tons, the Panzerkampfwagen VI Tiger I was an imposing presence on any battlefield. Its design philosophy centered on overwhelming firepower and impenetrable protection. At its core, the Tiger mounted the formidable KK-36 L56 88mm main gun, capable of penetrating 100mm of armor at a range of 1,000 meters. This capability allowed it to engage and destroy most Allied tanks, including the M4 Sherman and Churchill, from distances where they could not effectively retaliate. Frontal armor reached an impressive 100mm, rendering standard anti-tank ordnance like the 75mm guns on Sherman tanks largely ineffective. The psychological impact of facing such a heavily armored and potently armed vehicle profoundly affected Allied operational planning and troop morale in the summer of 1944. General Dwight D. Eisenhower himself acknowledged the Tiger's prowess, noting its ability to strike fear into the hearts of our tank crews. An engineering marvel, its combat effectiveness was unquestionable. Yet this pursuit of dominance led to a complex, perhaps over-engineered, mobility system. A defining feature of the Tiger I was its intricate overlapping and interleaved road wheel suspension system, a visually distinct arrangement unique among World War II heavy tanks. This design, coupled with exceptionally wide 725mm tracks, aimed to distribute the tank's immense weight, significantly reduce ground pressure, and enhance cross-country performance across the varied, often challenging European terrains. While it undeniably provided superior ride comfort and excellent traction, this sophisticated mechanism created a densely packed, confined space between the layers of road wheels and the track itself. The distinctive Schachtellaufwerk system, an interleaved and overlapping road wheel design, was a core tenet of German heavy tank engineering, most prominently featured on the Tiger I. This intricate setup positioned large road wheels in 3 rows, with outer wheels overlapping inner ones. The engineering rationale was sound. Such a configuration distributed the tank's immense 56-ton weight across a wider track surface, significantly reducing ground pressure. This translated into superior off-road performance, allowing the Tiger to traverse soft terrain that would bog down lighter Allied vehicles. The system also provided a remarkably smooth ride for the 5-man crew, enhancing gun stability and reducing fatigue during long engagements, crucial for accurate fire from its formidable 8.8cm KK-36 main gun. However, this sophisticated design, while offering clear tactical advantages, introduced a significant operational vulnerability. Each side of the Tiger I utilized 24 large road wheels, arranged in a complex pattern around a series of torsion bars, each wheel meticulously bolted to the hull. These wheels guided the 725-wide track, comprising 72 individual links. The sheer density and overlapping nature of these wheels, particularly the tight tolerances between the inner and outer rows, created numerous narrow channels and confined spaces. These gaps, often only a few centimeters wide, were critical snag points. These constricted spaces, inherent to the interleaved design, became a mechanical Achilles heel. Debris, mud, or ice could readily accumulate within these channels, causing the wheels to freeze in colder climates or requiring extensive, time-consuming maintenance to clear. More critically, these narrow corridors provided precisely the leverage a strong, linear obstruction could exploit. A simple, robust piece of material, if introduced into these specific gaps, could bind the rotating road wheels, snagging the track links as they passed. The enormous kinetic energy of the 56-ton vehicle, combined with the sheer rotational force of the tracks driven by the Maybach HL230 P45 engine, would then transform this minor snag into a catastrophic jam, tearing apart the delicate suspension components and immobilizing the tank almost instantly. This engineering marvel, designed for robustness, thus harbored a fatal structural susceptibility. Among the American ranks in the summer of 1944, Corporal James Mallister of the 35th Infantry Division stood out not for his combat prowess alone, but for a keen, almost intuitive understanding of mechanical systems. Before the conflict, Mallister had worked as a skilled mechanic, a trade that honed his eye for intricate engineering and potential points of failure. This background would prove unexpectedly vital. In early July 1944, during a lull in the intense fighting near St. Lo, Mallister's platoon came across an abandoned Panzerkampfwagen VI a Tiger I, partially submerged in a bomb crater. Its engine compartment had sustained direct hits, but its running gear remained largely intact, offering an unprecedented opportunity for close inspection. Most soldiers would have simply noted its formidable armor or large 8.8-centimeter KK-36 main gun. Mallister, however, focused on its unique Schachtellaufwerk system. He spent nearly an hour examining the massive tank, particularly its complex interleaved road wheels. He knelt, tracing the precise, narrow channels that ran horizontally between the large, overlapping steel wheels and the track links. There were 24 such wheels per side, creating a labyrinthine series of gaps. Mallister observed how these tightly packed components, designed to distribute the tank's 56 metric tons across soft terrain, also created numerous confined spaces. Any solid object, he mused, introduced into these specific conduits could act as a wedge. He considered the sheer momentum of the behemoth. A linear obstruction, he realized, if robust enough to resist immediate shearing, could snag the track links as they rotated, forcing a binding action against the intricate wheel structure. Those tight tolerances, he later recalled, meant there was nowhere for a foreign object to go but to jam. His observation was precise. A simple, well-placed impediment could exploit the very complexity that made the Tiger so formidable. Normandy in the summer of 1944 was a labyrinth of ancient hedgerows, sunken lanes, and dense orchards. This Bocage country, stretching for miles inland from the D-Day beaches, transformed the Allied advance into a brutal, claustrophobic grind. Here, the vaunted long-range accuracy of the Tiger I's 88mm KK-36 main gun was severely curtailed. Engagements typically occurred at distances under 200 meters, nullifying its inherent ballistic superiority over Allied tank guns. Yet the Tiger's imposing 100mm frontal armor and 80mm side plating remained an almost impervious shield, a death trap. For American infantry, often pinned down by German machine gun fire, the situation was desperate. Their supporting Sherman tanks, armed with 75mm and 76mm rounds, simply watched their shells bounce off the Tiger's hull. General Omar Bradley, commander of the U.S. First Army, noted the profound difficulty, stating, "Every yard was purchased at a heavy price in blood and steel." The close-quarters nature of Bocage fighting meant that while Allied anti-tank weapons like the M1 bazooka could theoretically penetrate the Tiger's thinner rear or top armor, achieving such a shot was exceedingly rare. Against a moving, vigilant target, it was fraught with peril. A direct assault often required a suicidal dash, leaving soldiers vulnerable to the accompanying German panzer grenadiers. Casualties mounted rapidly, particularly within infantry platoons tasked with clearing these treacherous lanes. This seemingly insurmountable challenge demanded a radical shift in approach. Mallister's platoon, Alpha Company of the 12th Infantry Regiment, held a forward position near St. Lo around July 10, 1944. Their sector bordered an unusually wide open field, a tactical anomaly in the otherwise close-quarter Bocage landscape. Suddenly, distant engine sounds grew into a distinct growl. Scouts quickly reported the unmistakable silhouettes emerging from the tree line. 4 Tiger I tanks, panzers of the 101st SS Heavy Panzer Battalion, advanced methodically across the terrain. This was the infantryman's nightmare scenario. The sheer mass of each 56-ton vehicle, combined with the distinctive 88mm KK-36 main gun, immediately conveyed an overwhelming threat. Conventional infantry anti-tank weapons like the M1 bazooka or the 57mm anti-tank gun had critically limited effectiveness against the Tiger's 100mm frontal armor. You just didn't engage a Tiger head-on, Lieutenant Arthur Jenkins, Mallister's platoon leader, would later recall. It was suicide. Your best bet was to run or pray for air support. Their advance was coordinated, each Tiger maintaining formation, their presence radiating a silent, destructive power across the contested Norman landscape. These armored behemoths represented the spearhead of a localized German counterattack aimed at dislodging the American salient. Tactical doctrine for dealing with such heavy armor dictated evasion or flanking maneuvers, neither of which was a viable option for the entrenched platoon. For Mallister and his men, the approaching Tigers were not merely targets. They were an embodiment of the Wehrmacht's technological superiority, a seemingly unstoppable force bearing down on their meager defenses. The outcome of this specific confrontation would determine not just the fate of their platoon, but potentially the viability of their entire sector. As the first of the 4 Panzerkampfwagen Tiger B tanks emerged from the thick hedgerows, its 8.8cm KK-36 main gun traversing slowly, Corporal James Mallister felt the familiar dread grip his gut. His M1 Garand felt impossibly light against the 56 tons of steel bearing down. The sheer kinetic mass and devastating firepower of the Tiger I had demoralized entire platoons. Yet, amidst the rising panic, a distinct memory flashed through his mind. The abandoned Tiger he had examined days prior, specifically its intricate, overlapping road wheels. He recalled the narrow, almost precise gaps between the interlocked wheel sets, designed for optimal weight distribution and traction across varied terrain. He had noted the complex dance of the inner and outer rows of wheels. This innovative feature, however, presented a labyrinth of channels where foreign objects could become lodged. The immediate threat of the advancing German armor solidified this observation into a desperate, audacious plan. Mallister knew he needed something simple yet effective to exploit this unique design. His solution was elegantly brutal: a length of common steel telephone wire scavenged from a downed communication line. The concept was straightforward. As the Tiger advanced, the wire would be stretched across its path, designed to be caught by the frontmost interleaved road wheels or the primary drive sprocket. Once entangled, the continuous rotation of the track system would inevitably pull the taut wire deeper into the narrow tolerances between the overlapping wheels and their suspension arms. This violent ingress would rapidly foul the tightly packed mechanism, binding the track links and potentially twisting the delicate torsion bar suspension components. The immense forces generated by the 650 horsepower Maybach HL230P45 engine would be channeled into self-destruction. Instead of propelling the tank, the energy would tear at the track or lock the entire system solid. A single strategically placed obstruction could render the formidable Tiger immobile. The leading Panzerkampfwagen VI I, likely commanded by Oberleutnant Karl-Heinz Lorenz of the 101st SS Heavy Panzer Battalion, rumbled forward. Its 56 metric tons represented the apex of armored engineering, advancing with perceived invulnerability. As the behemoth crossed the narrow farm lane near Sainte-Mère-Église, the taut wire, barely visible against the churned earth, caught the edge of its outermost road wheel. The powerful rotational force of the 720mm wide track, driven by the 650 horsepower Maybach HL230P45 engine, immediately pulled the steel strand inward. It was drawn inexorably between the closely spaced interleaved road wheels, wrapping itself tighter with each revolution around the hub and suspension arms. This simple obstruction, now firmly lodged, began to bind the intricate system. The track, designed for powerful traction, became its own undoing. Within seconds, the metal-on-metal friction escalated. The wire, acting as a crude but profoundly effective wedge, forced itself into the narrow channels between the overlapping wheels, distorting their alignment. A screech, then a grinding roar ripped through the air. The vast engine power, instead of propelling the vehicle forward, was locked in a violent struggle against itself. The track, under tremendous tension, seized completely. The lead Tiger, later designated 211 by Allied intelligence, lurched violently, its forward momentum ceasing abruptly. The vehicle pitched slightly as its left track became an immovable object, its complex torsion bar suspension units twisting under the sudden asymmetric strain. The intricate overlapping road wheels, once a marvel of German design, were now a tangled, compromised mess, their function nullified by a few meters of common steel wire. Its formidable presence was instantly neutralized. While undeniably ingenious, this specific tactic relied heavily on both surprise and the precise constricted terrain of the Bocage. German panzer crews, rigorously trained to scan for conventional mines and anti-tank obstacles, rarely anticipated such a low-tech, precisely executed vulnerability. Had the Tiger been operating on open ground or at higher speeds, the outcome might have differed significantly, as the wire could have been simply snapped or flattened without critical engagement. The lead Tiger, a formidable 56-ton PZK Kampfwagen VI I, ground to an abrupt halt. A simple steel wire, inextricably fouled within its complex interleaved road wheel system, had locked its track mechanism. This was no explosion, no penetration of its formidable armor. Instead, a mechanical seizure rendered the behemoth instantly immobile. Its colossal 88mm KWK-36L56 main gun, still fully functional, now faced a single fixed arc. The very design intended for superior cross-country performance across the rough bocage terrain had become its undoing. The narrow farm track, a typical feature of the Normandy Bocage, now became a choke point. With the lead Tiger stalled, the three subsequent panzers of the 501st Heavy Panzer Battalion, unable to bypass the crippled lead vehicle, were forced to halt directly behind it. Their powerful engines idled. Their fearsome 88mm cannons, constrained by the road's geometry and the unmoving obstacle, pointed impotently forward. This rapid immobilization negated the offensive momentum of the entire Tiger formation, transforming a spearhead into a static target. The operational flaw wasn't in the Tiger's armor or firepower, but in its fundamental ability to move, turning an otherwise unstoppable war machine into a stationary pillbox. Despite this immediate tactical success, the immobilized Tigers were far from helpless. Their thick frontal armor, up to 100 millimeters on the hull, remained impervious to most American anti-tank weapons available at that range. The devastating 88mm guns could still engage any exposed infantry or light vehicles. German tank crews, trained for disciplined aggression, would have prepared to defend their positions, transforming their immobile tanks into formidable, albeit static, strong points. This defensive posture, however, came at a profound cost to their operational objectives, shifting their role from offensive breakthrough to mere survival. With the German armor suddenly rendered inert, the Allied response was swift and coordinated, capitalizing immediately on the tactical paralysis. The moment the lead Tiger shuddered to a halt, followed swiftly by its comrades, forward observers from the U.S. 1st Infantry Division relayed target coordinates. Within minutes, a pre-registered artillery battery, likely a M101 howitzer unit, unleashed a concentrated barrage. This suppressive fire blanketed the surrounding hedgerows and fields, effectively isolating the supporting Panzer Grenadier infantry from their now immobile heavy armor. The objective was clear: prevent any attempt by German infantry to secure the disabled tanks or provide counterfire, turning the isolated Tiger crews into targets. Even crippled, a Tiger remained a dangerous adversary. Its 8.8-centimeter QK-36 main gun was fully operational, capable of tearing through any Allied tank from the front. The German crews, though confined to their static positions, would have maintained situational awareness, prepared to defend their positions, transforming their tanks into formidable, albeit fixed, strong points. This defensive posture, however, came at a cost to their operational objectives, shifting their role from offensive breakthrough to mere survival. The subsequent arrival of a Sherman tank platoon, likely from the 743rd Tank Battalion, shifted the dynamic entirely. Operating under radioed instructions from Mallister's command, the M-Force executed a classic flanking maneuver. They exploited the terrain, using the dense bocage to mask their approach, then emerged to engage the stationary Tigers from their critically vulnerable flanks and rear. A 75mm round striking the thinner side armor of a Tiger, particularly the engine compartment or the rear of the turret, could ignite fuel or detonate ammunition. Facing an untenable position, isolated from infantry support and under direct, accurate fire from maneuverable tanks exploiting their design vulnerabilities, the crews of the 4 Tiger tanks had few viable options. Surrender became an imperative. Upon securing the battleground, Allied technical intelligence teams converged on the immobilized Tiger I Ausf. Their initial assessment was critical. The exterior bore the usual scars of combat, but the immediate focus quickly shifted to the drive system. What they observed confirmed Mallister's audacious hypothesis. The massive 725mm wide Ostketten track, designed for superior flotation on soft ground, lay grotesquely twisted. Several outer track links, specifically the connecting pins and guide teeth, were visibly warped or completely sheared. It was a clear, undeniable mechanical failure. Closer inspection revealed the true genius of the corporal's improvisation. The simple, high-tensile strength communication wire had not merely snagged. It had been drawn deep into the intricate labyrinth of the interleaved road wheel system. As the 56-ton machine attempted to advance, the wire became irrevocably entangled between the tightly packed inner and outer sets of rubber-rimmed steel wheels. Enormous torque from the Maybach HL230P45 engine, instead of propelling the tank, was violently channeled into the obstruction. This immense force bent several delicate suspension arms supporting the innermost road wheels. They locked against the chassis. The continuous strain caused multiple track links to buckle and ultimately snap, severing the integrity of the track chain. This post-mortem dissection underscored the inherent vulnerability baked into the Tiger's sophisticated design. The interleaved road wheels offered unparalleled ride quality and superior weight distribution, but their complex arrangement created numerous narrow channels. These tight tolerances, a hallmark of German engineering precision, became a critical liability. A foreign object, flexible yet strong like the wire, could easily ingress these gaps. It became trapped. The sheer mechanical advantage of the moving track against a fixed obstruction, magnified by the engine's power, turned the system against itself. It was the epitome of an Achilles heel, a tiny, overlooked vulnerability capable of crippling a titan. However, it is crucial to avoid oversimplifying the broader strategic context. Mallister's tactic, though devastatingly effective in this specific instance, was hardly a universal panacea for the omnipresent Tiger threat. German engineers were not entirely oblivious to the maintenance challenges and potential vulnerabilities of their complex track systems. But their design priorities often leaned towards performance and protection over field simplicity. The interleaved wheel system offered tangible advantages in cross-country mobility and improved armor protection. It presented fewer direct paths for anti-tank rounds to penetrate the hull behind the wheels. Indeed, subsequent German designs and field modifications would attempt to address some of these issues, often streamlining wheel arrangements or adding protective skirting. This demonstrated a continuous, if sometimes belated, adaptation to battlefield realities. The ingenuity demonstrated by Corporal Mallister quickly disseminated through the Allied ranks, albeit through informal channels. Word of mouth and unofficial field reports from units engaged in the relentless hedgerow fighting, such as elements of the 1st Infantry Division and the 29th Infantry Division, began to circulate. Combat engineers and infantry platoons, often facing insurmountable odds against the heavily armored German behemoths, started to actively seek out discarded telephone wire, barbed wire, or even heavy-gauge electrical cable. These materials became the improvised components for what some soldiers humorously termed tiger traps, a simple yet devastatingly effective countermeasure. German intelligence, though not always swift in its assessments, eventually registered these peculiar incidents. Reports of Tigers found immobilized with their intricate road wheel systems jammed and track pins snapped began filtering back to various panzer divisions and eventually to the Oberkommando des Heeres. OKH initial advisories from Army Group B headquarters in August 1944 warned of feindliche Sabotageakte gegen Laufwerk, enemy sabotage acts against running gear. German engineers attempted various reactive measures, including increased infantry screening for tanks in close terrain and, in some instances, even welding small deflector plates or additional armor skirts lower down on the hull sides. However, these were often ad hoc solutions, adding weight and complexity without addressing the fundamental vulnerability of the exposed, multi-layered interleaved road wheel system. The ingenuity demonstrated by Corporal Mallister quickly disseminated through the Allied ranks, albeit through informal channels. Word of mouth and unofficial field reports from units engaged in the relentless hedgerow fighting, such as elements of the 1st Infantry Division and the 29th Infantry Division, began to circulate. Combat engineers and infantry platoons, often facing insurmountable odds against the heavily armored German behemoths, started to actively seek out discarded telephone wire, barbed wire, or even heavy-gauge electrical cable. These materials became the improvised components for what some soldiers humorously termed tiger traps, a simple yet devastatingly effective countermeasure. German intelligence, though not always swift in its assessments, eventually registered these peculiar incidents. Reports of tigers found immobilized with their intricate road wheel systems jammed and track pins snapped began filtering back to various panzer divisions and eventually to the Oberkommando des Heeres. Initial advisories from Army Group B headquarters in August 1944 warned of feindliche Sabotageakte gegen Laufwerk, enemy sabotage acts against running gear. German engineers attempted various reactive measures, including increased infantry screening for tanks in close terrain and, in some instances, even welding small deflector plates or additional armor skirts lower down on the hull sides. However, these were often ad hoc solutions, adding weight and complexity without addressing the fundamental vulnerability of the exposed, multi-layered interleaved road wheel system. While remarkably effective in specific, constrained environments like the dense bocage where concealment was abundant, this improvised tactic was not a panacea. Its utility was primarily limited to narrow roads, defiles, or choke points where Allied infantry could approach unseen and deploy the wire with an element of surprise. In open terrain or against well-supported tiger formations maintaining robust infantry screens, the risk to the deploying soldiers was prohibitively high. Furthermore, the tactic demanded precise placement and timing. A poorly executed attempt would simply allow the tiger to roll over the obstruction harmlessly. Nevertheless, the widespread adoption of such a basic, low-tech solution underscored a critical design flaw in Germany's engineering philosophy, an almost obsessive pursuit of technical superiority that, at times, overlooked battlefield practicality and the simple resilience of systems under duress. The episode of Corporal Mallister's ingenuity with the Tiger was more than a localized tactical victory. It served as a stark illustration of a fundamental philosophical divergence in wartime engineering. Germany, driven by a pre-war cultural emphasis on precision and individual excellence, pursued a doctrine of crafting technologically superior, albeit highly complex, platforms. Their Panther and Tiger tanks exemplified this dedication to unparalleled quality and formidable combat power, often at immense manufacturing cost. Conversely, the Allied powers, particularly the United States, prioritized mass production, standardization, and logistical resilience. Their approach favored simpler, more robust designs that could be churned out in vast quantities and maintained with relative ease in the unforgiving conditions of the battlefield. The Tiger I, while a terrifying adversary on paper, embodied the strategic pitfalls of this elaborate design ethos. Its intricate overlapping road wheel system, while providing excellent weight distribution and mobility over varied terrain, demanded constant, specialized maintenance. The sheer volume of high-grade steel and skilled labor required for each unit meant that only approximately 1,350 Tiger I tanks were ever produced throughout the conflict. Field repairs necessitated heavy lifting equipment and extended downtime. This meticulous, almost artisanal approach choked German industrial capacity, diverting critical resources from other vital war efforts. In stark contrast, Allied designs like the American M4 Sherman embraced pragmatism.
The Sherman, though often outmatched individually by heavier German tanks, was designed for straightforward mass production. Over 50,000 units were ultimately manufactured. This enabled Allied commanders to overwhelm numerically superior foes through sheer weight of numbers and superior tactical deployment. Its modular construction permitted rapid component replacement, and a trained crew could often perform repairs with standard tools, frequently returning a damaged tank to action within hours. General George S. Patton famously remarked, "I'd rather have 1,000 Shermans than 10 Tigers." This philosophy acknowledged the brutal realities of industrial warfare. Quantity and maintainability often trumped individual technological superiority. Yet, it is crucial to acknowledge that Germany's engineering philosophy was not without its merits, particularly in the initial phases of the war. Early blitzkrieg successes were often predicated on innovative, sometimes complex designs like the Panzer III and IV, which, at the time, offered significant advantages over their opponents. Furthermore, the individual combat prowess of a Tiger or Panther tank against multiple Allied counterparts was undeniable, forcing Allied designers to constantly innovate and adapt. Their focus on raw combat effectiveness and crew protection often resulted in formidable machines that psychologically intimidated the enemy. The inherent flaw lay not in the pursuit of quality itself, but in the inability of a war-strained industrial base to sustain such an intensive, resource-heavy strategy against a global coalition with far greater manufacturing potential.
Mallister's simple wire, therefore, exposed more than just a weak point in a tank's track system. It laid bare the Achilles heel of an entire national engineering strategy, brilliance that became self-defeating complexity. The very attributes that made the Tiger formidable, its layered armor, powerful 88mm gun, and sophisticated suspension, were inextricably linked to its vulnerabilities. Immense weight, excessive resource consumption, and an unforgiving maintenance schedule. This fundamental disconnect between design aspiration and industrial reality ultimately proved to be a strategic liability, contributing significantly to Germany's inability to sustain its war machine against the relentless, adaptable, and numerically superior Allied forces. The incident was a vivid demonstration that sometimes the simplest solutions can unravel the most complex designs. The ultimate legacy of the Tiger I's Achilles heel lies not just in a single incident, but in its profound commentary on engineering philosophy under duress. Germany, committed to technological supremacy, produced fewer than 1,350 Tiger I's, each costing approximately 250,000 Reichsmarks and demanding extensive maintenance, often 10 to 15 track hours for every 100 kilometers traveled. This intricate design, while formidable on paper, proved a strategic liability. The incident in Normandy starkly underscored the critical balance between complexity and robustness, illustrating that even the most advanced machinery can be undone by an oversight in a seemingly minor component. Corporal James Mallister's unassuming ingenuity exposed a fundamental vulnerability. His wire trick rapidly disseminated through Allied intelligence channels and field manuals across the 1st U.S. Army and the British 21st Army Group, becoming a recognizable, if specialized, countermeasure. It transformed the perception of the Tiger from an invulnerable behemoth to a machine with a quantifiable, exploitable weakness. Mallister, despite his pivotal insight, remained a humble figure, embodying the resourcefulness that often defined the Allied fighting spirit against overwhelming odds. However, it is crucial to maintain perspective. The wire trick, while effective in specific ambushes, was never a universal panacea against the Tiger. The tank remained a potent weapon system, its 88mm KK-36 L-56 gun capable of penetrating virtually any Allied armor at range.
German engineers, quick to learn from battlefield feedback, soon implemented countermeasures like additional track guards and later in the Tiger II, a revised track design that eliminated the exposed channels. The Tiger's reputation, earned through numerous engagements, was not solely diminished by a single improvised tactic.
Nevertheless, the incident endures as a powerful case study in military procurement and engineering. It highlights the indispensable value of anticipating all failure modes, especially under combat conditions where improvisation is paramount. Modern defense contractors meticulously employ failure mode and effects analysis to identify such vulnerabilities. Mallister's simple wire, pitted against 56 tons of precision German engineering, serves as an enduring testament to the principle that elegant simplicity, when applied with acute observation, can sometimes unravel the most complex designs, leaving a lasting, understated legacy of human ingenuity.